All right, sorry, the recording did something a little weird there. All right, so we're going to do question 2. All right, so researchers on a boat are investigating plankton cells in a sea. At a depth of 8 meters, the density of plankton cells in millions of cells per cubic meter is modeled by P of H equals, and then they give you this awful function. Now that's for 0 to 30. So this is like depth into the ocean, like 30 meters down. So that P of H is for 0 to 30. That's the density of plankton. And then F of H is for greater than 30. So it's not unlike the one that we just did about the escalator, where we had one rate for 0 to 300, and then the rate was 0 for after 300. This is kind of like that. We have P of H for 0 to 30, and then F of H for everything bigger than 30. And they don't give us a function for F of H. All right, so letter A says find P prime of 25, which is easy enough. We're just going to put that in the calculator, and then we have to explain what it means. So in your calculator, we're going to go to the math menu, and choice 8 is the derivative. So we're going to hit math 8, d dx, and then I'm going to put the function for P of H in there. And oh my gosh, it is horrible. I know it says H, but I'm going to type it. It is 0.2 x squared, and then e to the power negative 0.0025 x squared. And we want to do this such that x equals 25, and that will give us our answer. So negative 1.179. All right, so that's what we get for the answer. And then we have to explain what it means. So P of H gives you the density of plankton in millions of cells per cubic meter, but this is now a rate of that. We did a derivative, so it's going to be per meter. It's going to be cubic meter per meter. This problem's weird with the units because your density is plankton cells per cubic meter. Like that's your number of cells that are there, and then we're doing a rate of that. So anyway, at a depth of 25 meters, that's what we plugged in, 25. So at a depth of 25 meters, the density is decreasing, because this is negative. So decreasing at a rate of 1.179, oh gosh, what was it, million cells? Million cells per cubic meter per meter. So your amount of cells is cells per cubic meter, but then we did a rate of that, so per meter, and it's at a depth of 25 meters. Oops, that went off the page a little bit. Sorry, I'm having to toggle back and forth between reading the question and being able to see what I'm writing. All right, letter B. Consider a vertical column of water in this sea. So like you're on a boat and then like you have a column of water going down into the sea. Cross sections are a constant area of 3 square meters. To the nearest million, how many plankton cells are in this column of water between 0 and 30? All right, easy enough because that's you're just accumulating from 0 to 30. The only thing is you have to multiply by 3 because it says 3 square, your cross sections are a constant area of 3 square meters. So 3 times P of H DH, and we're going to put that in the calculator. When I type it, I'm going to put the 3 out front though, because that's just going to be a little easier to type. So 3, math 9, 0 to 30. Oh gosh, and then I'm going to have to type this P of H again. 0.2 x squared e to the power negative 0.0025 x squared dx. And I got 1675.414. Let me see, did they say to round that to the nearest whole anything? Oh, to the nearest million. So 1675 million cells. So in that column of water that's going down to a depth of 30, the cross sections were 3 gosh, what was it, 3 square meters. So we've got 1,675 million cells in that amount. All right, part C. Now we're introducing this function u such that 0 is smaller than f of h is smaller than u of h. So f of h is stuck in between those. F is smaller than u is what they're saying. And this is for depths greater than 30 meters. And it says the integral from 30 to infinity, so like down infinitely into the ocean, they're telling us that is 105. So we're using the column of water from part B that we just talked about is K meters deep, where K is bigger than 30. I'm going to show you a picture of what this is going to look like here. So like this is the ocean. Let me come back over to make sure I can see what I'm drawing here. So say that's the ocean. Here's your boat on top of the sea. And then this is this column of water going down into the ocean. So here's a depth of 30 meters. And then further down, even below that, we've got this depth of K meters. So K is deeper than 30 is what's going on. All right, so write an expression involving one or more integrals that'll give the number of plankton cells in millions of the entire column. So we want the number of plankton cells all the way down to K. Now we already did from 0 to 30, we're just going to need to add on to that. So it's going to be what we just did. Integral 0 to 30, 3p of h dh plus, because that's going to give us, down to 30 meters, plus, and then we want to go from 30 to k, but that function, remember, p of h was only to 30 meters. This was p of h. Below that was f of h. So, you just have to make sure you pick the correct function. All right, so that's all they're asking for there. Write integrals that are going to give you the number of cells in that column of water. So there's that. And then it says, explain why the number of plankton cells in the column is less than or equal to 2,000 million. All right, so we're going to have to use this, what was it? F of h is smaller than u of h. Information that they gave us. So this is going to be a little bit of writing here. Since f of h is in between 0 and u of h for depth bigger than 30 meters. And I'm pretty much just copying that from the problem. Like, want to recopy what they gave you. All right, so since that's true, sorry, let me toggle over again so I can see what I'm writing here. All right, so since that is true, I'm going to look at the integrals here. I'm going to bring this 3 out front. 3 and our integral from 30 to k for f of h dh would have to be smaller than 3 times the integral from 30 to k of u of h dh. So since f is smaller than u, this integral is going to have to be smaller than this integral. I know it's a lot of notation, a lot of weird writing, but all we're saying is f is smaller than u, so this integral is going to be smaller than this integral. And that in turn is going to be smaller than if we went to infinity. Because from 30 to k is just here. If you go, down infinitely, which you can't, you go through the other side of the earth, but infinitely is going to be smaller. And that would be equal to 3 times what they gave us this in the problem. Gosh, what was it? I have to go back. Sorry, 2 different screens here. They told us that integral from 30 to infinity u of h dh is 105. This would be equal to 3 times 105, which would be 315. So we know that this, zoom out a little bit here. So we know that this integral is going to be smaller than 315. But we have to add on that 1,675 million cells we had for the first part. This is just talking about this second integral here. Remember, we have that first one. So the total cells is less than or equal to this 1,675 million plus this 315 that we got here, and that is equal to 1990 million cells. All right, so the total cells has to be less than this amount. And so therefore, you can throw a therefore in here. Therefore, the total is less than 2,000 million cells. So again, it's a lot to write, but we're just saying function f is smaller than function u, which is going to be smaller than going to infinity. They told us that one was 105 times 3, so we got 315. Don't forget to add on what you had for this part. And so the total has to be smaller than 2,000. I almost wish they had said prove that it's smaller than 1990, because that's the answer you end up with, but anyway. All right, and then part D, which is actually easier than part C, in my opinion. Part D, the boat is moving on the surface of the sea at times greater than or equal to 0. The position of the boat is given by x of t comma y of t. So this is a parametric equation here. They give you x prime and y prime, time is in hours, find the total distance. We just need to remember the formula for total distance. It's going to be integral, what was the interval they gave there? It says find the total distance from 0 to 1. So it's going to be integral from 0 to 1, and then a great big square root, and it is x prime of t squared plus y prime of t squared dt. And we're going to put that in the calculator. And again, that's just a matter of remembering that formula. So if you remember the formula, you're just going to type it in and get your answer. This will be math 9, 0 to 1, gigantic square root. Let me go back and get the equations here. So parenthesis, x prime was 662 sine. Oh, you know what? I need to change my mode back to radians. We're doing degrees and pre-calc right now. 662 sine of 5x, and then close parenthesis squared plus, all right, now we're going to do y prime, which is 880 cosine of 6x, close parenthesis squared dx. And it's a monster to type, but that'll just give you your answer when this eventually comes up again. All right, there we go, 757.455, or you can round up. Oh gosh, and what were the units there? I think it was meters, wasn't it? We're just finding the total distance. Yeah, so total distance in meters. So for this problem, I think this was the harder out of the two that we did today, for sure. But there's a lot that's manageable. Part D, if you remember this formula, you're going to get that as long as you don't make a mistake typing it. So that is a lot to type, but it's just know the formula, plug it in. Part C, this was a lot to explain here, but you could at least get this part, which let me see how many points that was worth. And I'll post the scoring guide here in just a minute. Yeah, you get a point for this. So even if you struggled with the explanation, if you wrote the integrals, you would get a point. And then part B was just setting up an integral. And part A, this is just putting it in your calculator. Again, if you struggled with explaining it, you would at least get a point for this part. So there's some of it that's not too bad. This part was okay. That was tough. I think part B was okay. This part of part C was okay. This was a mess. And then if you knew this formula, you'd probably get part D. So there is some of that that was manageable.